We recently looked at the slope of a line. We don't want to forget that. So we want to transition into actually finding the equations of lines. Let's say we start with a point and a slope. A point and a slope. Say we have a point, let's call it P. Say that point is x1, y1. And also we have a slope. We're given that as well. That's going to be a number. We're going to call it m. So you start with your point, x1, y1. And then let's do rise over run, the slope m. So that's my m, that's my rise over my run. That's going to be a certain rise over run. You'll be given that. And that's going to take us to another point. Starting at the first point and rising and then running, it's going to take you a second point. Let's call that point Q right there. Now that point Q, we're not given that, so we're going to call it x comma y, right? They're unknowns, they're variables, x and y. And you connect the 2 points, the P and the Q, and you get a line, right? Now, if I were writing this out, using the formula for slope, we'd have what? M is equal to y2 minus y1 over x2 minus x1. So we know here, x1 and y1, those will be given numbers. x2 and y2, though, are unknown, right? They're unknowns. They're unknowns. They're red x and red y, respectively. So let's go ahead and plug in here. M is going to be known. That's going to be blue. Y2 is going to be unknown. That's going to be red. Minus y1 is going to be a known number. We'll make it blue. And then x2, that's going to be a red x, right? It's unknown. And then minus x1 in blue. x1 will be known. So basically I've replaced my y2 with an unknown red y and my x2 with an unknown red x. And we want to get rid of that fraction, x minus x1. And to get rid of a fraction, you want to multiply both sides by the common denominator here, which is x minus x1. X minus x1. If I multiply the right-hand side by x minus x1, I've got to also multiply the left-hand side by x minus x1. So here, the bottom on the right-hand side cancels with x minus x1. Scroll a little. Come on, let's scroll a little. It's a shame. Doesn't want to scroll. Let's try it again. Scroll. There we go. So in fact, it looks like we're going to have yep, doesn't want to work. Doesn't want to work. X minus x1 times m equals, what's left on the right-hand side? Well, the denominator canceled with the x minus x1. So the x minus x1's canceled. And it looks like we're left with a red y minus y1. So here we have a nice little formula for the equation of a line when you have the point and a slope. When you have a point and a slope. So we want to write this down formally. We're going to call this the point-slope form. Point-slope form for the equation of a line. Point-slope form for equation of a line. And it says the following: the line L passing through the point P1, or let's call it P, just P, x1, y1, having slope m, has equation This is not writing at all right now. Let me get another crappy stylus. Y minus y1 equals m times x minus x1. So here is our point slope form for the equation of a line. So it says the line that passes through x1, y1 and has a slope of m has the following equation. Y minus y1 equals m times x minus x1. Right? That's the same equation as this, just written a little differently, a different order. So you definitely want to remember this formula. This is when you have a point and a slope. A point and a slope given. Now let's see if we can work an exercise. Here's an exercise. Exercise 1. So let's see, find the equation of the line L. Find the equation of the line L. Here is the description of the line L. L is passing through the point for -1 and has slope how about -1/4. So we want to find the equation of a line that goes through this point and has that slope. So let's go ahead and figure out what the equation of the line is. So first of all, we need a point. We have our point right here, right? Right? It's going to be 4, -1. So you have a x1, y1. Secondarily, you need a slope. Which is what? M -1/4. So after that, you're going to use point slope form. Right? Point and a slope, you use point slope form. To find the equation. So you're going to have y minus y1 equals m times x minus x1, close parentheses. So I have y minus, in place of the y1 here, we're going to put a -1 equals m. In place of the m right here, we're going to put -1/4. Then we have a parentheses, x minus, and then x1, we're going to put a 4. Put a 4 for x1. Close that parentheses. Okay. Now, we want to clean this up. So we have a double negative here on the left-hand side, so the double negative makes a plus. And we want to simplify this. If I simplify this, I can distribute the negative 1/4 through the parentheses on the right-hand side. So here goes. I'm going to go all green. On the left-hand side, I got y. Double plus is plus 1. And on the the right-hand side, when I distribute, I get negative 1/4 times x is what? Negative 1/4, and then an x beside it. Well, negative 1/4 x. And then when I take negative 1/4 times negative 4, I'm going to get a positive 1. Right? Let's write that scratch word to the side. If I take negative 1/4 times, this is a negative 4 right here. Negative 4. Negative 4 is the same thing as negative 4 over 1. Right? If you multiply those two things together, I'm going to have a negative 1 times a negative 4 is a positive 4. And then on bottom, I have a 4 times a 1. 4 times 1 is 4, so you do 4 over 4, which is a positive 1, right? Plus 1. Now, to continue simplifying this, I'm going to have to get y by itself. I'm going to subtract 1 from each side. And I'm going to get the equation y, positive 1, negative 1 cancel, equals minus 1/4 times x. And the 1 and the negative 1 cancel also on the right. So you get y equals negative 1/4 x. That is the equation of the line that passes through the point 4, negative 1, and has a slope of negative 1 over 4. Okay, let's go on to another problem. Let's ask the question, find the equation of the line that has the following characteristics. L passes through the point 55, 3, and has a slope of 0. Has slope m equals 0. So again, I have a point and I have a slope. So I can use the point-slope form to find the equation of a line. So here is my point. Right, I have 55, 3. So my x1 is 55, and my y1 is 3. And also we have a slope given. Here our slope is 0, m equals 0. So I can set up the point-slope form to get the equation of the line, point-slope form. Equation, where I have what? Y minus y1 equals m parentheses x minus x1 close parentheses. So plug in y minus a red 3, right? y1 was 3 equals what? 0, right? M is 0 times x minus 55. So it turns out that you really don't have to do any work on the right-hand side. On the right-hand side, you have what? 0 times something. 0 times anything is 0, so this is going to be equal to all 0 on the right-hand side. On the left-hand side, we just have y minus 3. Y minus 3. So right now we're simplifying this, right? We're simplifying. The goal is that you want to get y by itself. So if I add 3 to both sides, I'm going to get y equals 3. Now, let's think about this. Let's think about this very carefully. In one of the previous videos, we talked about what happens when you have a slope of 0. When you have a slope of 0 means you have a horizontal line. Horizontal line. That's a line going from side to side. And the equation of a horizontal line, notice here, is y equals 3 for the horizontal line that goes through this particular point, 55, 3. Let's draw a little picture. I'm going to draw a picture to the side. So imagine here is my y-axis. This is my x-axis. So let's say way out here we have 55 on the x-axis. And then up here we have 3 on the y-axis. So if I were to plot a point here at 55, 3, it would be right here, right? This red dot. That'd be my P. And we know that when you have a horizontal line, the slope is 0. Or rather, when the slope is 0, you have a horizontal line. So we're talking about this guy right here, line from side to side. And we call that simply y equals 3. Y equals 3. So notice there's no x showing up in that equation. It's just y equals 3. Yeah, so you can imagine, let's think about this for a moment, doing a table of values. A table of values. So let's do a table of values. This is another way of thinking about it, where you have x's and y's. X's and y's. So we know that the y is always 3. Right? 3, 3, 3, 3, 3. And the x is not specified in this equation, right? Y equals 3, that equation. The x is not specified. So the y could be anything at once. The y could be like -2. I'm sorry, the x can be -2, -1, 0, 1, and 2. Whatever, right? X can take on any value. Y is always 3. So if you were to actually plot these points, like, let's see, let's do little tick marks. 1, 2, 1, 2. So imagine here is -2, 3. That would be like right here. -1, 3 would be here. 0, 3 would be like here. 1, 3 would be like here. 2, 3 would be like here. So notice that all these dots are lining up into our horizontal line. So that's another way to think about it in terms of XY values, a table of values. So here's an important fact we should state. Fact. A horizontal line that means the slope is 0, m equals 0, with point, let's call the point x1, y1, has equation y equals y1. So you can remember that. So if you got a horizontal line, that means you got a slope of 0, and you got a point, then the equation of that line is y equals the y coordinate of the point it passes through. Now,